Okay, today, we're not going to learn any more properties. So that's kind of in the past. That was last week. Today is kind of more or less like a recap of everything we've done, and being able to, and kind of the goal for today is to be able to take a look at a figure and using its properties, being able to classify it. So without being like more or less, I guess, say tricked by kind of background knowledge, we're gonna use the properties that we came up with for the last week or so, and decide very reason why various figures have to be what we claim them to be. In this big space here, I got room to make it like a diagram or a chart of all the things that are quadrilaterals that we've kind of seen. So in the world of quadrilaterals, we have kind of the most general things are just any old quadrilateral. Is any old quadrilateral. And then we broke it into like 3 basic families. So there are the parallelogram family, where there were 2 parallel sides. There's the trapezoid family, where there's 1 pair of parallel sides. And then we also had the kite family, where there are no parallel sides, but 2 pairs of congruent sides. No parallel, but 2 pairs of congruent sides. Okay. We didn't have any special kinds of kites. They were just you're either kite or you weren't. We had kites. But each of these 2 parallelograms and trapezoids had kind of further specifications. So we had kind of even more specific kinds of these. Okay. Trapezoids, you could be a trapezoid, or if you also had 2 legs that were congruent, we had isosceles trapezoids. 2 not parallel, but 2 pairs of congruent sides. We had trapezoids. We had a specific type of trapezoid called an isosceles trapezoid. We said those were ones that kind of had this general shape, where we had parallel sides and congruent legs, parallel bases and congruent legs. It's kind of a general picture here. Parallelograms, there were 2 special kinds of parallelograms. So there are rectangles. What made a rectangle a rectangle? Okay, it's definitely parallelogram. So we got 90-degree interior angles. We also had rhombi, or a rhombus. What made a rhombus a rhombus? Brett? A rhombus is a rhombus if it's a parallelogram with 4 congruent sides.
Thank you.
A rectangle is a rectangle because it is a parallelogram that has 90-degree angles. And then we said if you combine forces here and get both a rectangle and a rhombus, then if you put those things together, then you make yourself a square. Okay. A square is both a rectangle and a rhombus. It has 90-degree angles, and it has 4 congruent sides. And that thing is called a square. 90-degree angles and congruent sides. Okay. And this is our basic family of quadrilaterals. Our goal today is to be able to differentiate, if I give you a diagram, is to be able to go back to the definitions of what makes these things, what makes each of these things themselves. Why is a rectangle a rectangle? Why is a diagram a rhombus? Why is a diagram a kite and not anything else? And go back through and decide what can we name these based on what we know about their properties. Okay? And moreover, not letting the diagram deceive you, and not just trusting on what the diagram kind of looks like, and instead relying on what the diagram actually tells you about it. So, for example, I've got a couple different pictures here. 3 actually very similar looking. Let's classify this with its given name. I'll tell you this is a parallelogram. So knowing this is a parallelogram, what's the best name for this parallelogram that we can get? What's this called? This is most certainly not a square. The best you can say this is a rhombus. Okay. So what we know about this is it's a parallelogram with 4 congruent sides. So it's definitely a rhombus. For it to be a square, it also has to have right angles. So do we know this is right angles? No. So the best name we can give this is a rhombus. Hold the middle one. What's the best name we can give the middle one? A square. Why is it a square? What makes that a square? Okay, so the diagonal's making a 90-degree angle. That tells you, since it's a parallelogram, what kinds of parallelograms have diagonals that are perpendicular. A rhombus has that. So this is at least a rhombus. Okay, so then from there we have to decide if it's a square, then it must also be a rectangle. So what makes this a rectangle as well as a rhombus? A rectangle from Friday has congruent diagonals as well. Are these diagonals the same length? Yeah. They're made up of each 2 parts of the same length. So since it has congruent diagonals and perpendicular diagonals, and the diagonals are perpendicular as well, then this must be both a rectangle and a rhombus, or the name for that is a square. Perpendicular diagonals and congruent diagonals makes this a square. Okay? This is not a square because it kind of looks like a square. This is a square because the diagonals are congruent and the diagonals are perpendicular. Okay? What's our last figure?
Rectangle.
Why isn't it a square?
Because sides are all congruent.
If we keep that in mind, we go back to the definitions, go back to the properties, and see what the best you can claim, then you'll be on the right path. If you just trust in what the diagram kind of looks like, I'm going to intentionally try to throw you off. Okay? I will try to, on the test on Wednesday, I will give you some things that look a lot like something, but unless you can prove to me why it's that, or explain to me what the properties are, and you understand what the properties are, then you might be kind of thrown for a loop. I'm going to try to throw some diagrams that are intentionally tricky. That you're going to need to really understand what the properties of these figures are. Okay? Similar to what I did up here. Okay? So let's see. Given this information, identify any of the quadrilaterals that fit this description. So now I'm going to force you to think about what the properties we've seen so far, be them of parallelograms or of rectangles or of trapezoids. Those things. Which one of these fit these categories? So we have some quadrilateral, A, B, C, D, that has at least one pair of congruent opposite angles. So let's think of some of these. Let's think of some figures that have congruent. That has at least one pair of congruent opposite angles. So let's start naming them. A rhombus. Okay. Rhombus for sure. There's a more general, this description actually fits a more general category. Parallelograms in general have 2 pairs of opposite angles, so it definitely has at least one. So anything that fits underneath that category of parallelogram certainly has at least one. In fact, they have two pairs of congruent opposite angles. So a rhombus is a parallelogram. A parallelogram is a parallelogram. What are some other figures that fit under this parallelogram category? Squares are parallelograms. What others? Rectangles. Are there anything else that has at least one pair of congruent opposite angles? So what are the other things? We've named 4 of them. What are the other 2 shapes of this? Kites and trapezoids, the only other 2 possibilities. Do trapezoids have congruent opposite angles? No, they don't. They have congruent base angle. Some of them do. Well, isosceles ones do, but trapezoids don't actually at all. Do kites? Yeah, by definition, they have one pair. Well, not in a theorem, not by definition, but in a pair. Kites, definitely. Kites for sure do. They were that pair that if we had a kite, then we said that the angle that's between the two different length sides are congruent, for sure. Kites have at least one. Let's see. How about some that have consecutive angles that are always supplementary? Okay, so consecutive angles. So if I pick any 2 and I add them together, then they'll be supplementary or add up to 180. Let's see. We definitely had a theorem about this for one general figure. Parallelograms, this is definitely true. For parallelograms. And if it's parallelograms, then it fits all of us more specific times. So, therefore, rectangles, rhombus, square. Are there any others? Trapezoids are always, consecutive angles are always supplementary. So I agree that a pair of base angles on the same side are supplementary, but I want all consecutive angles to be supplementary. So what if I picked, say, these 2? Are those 2 necessarily supplementary? Not generally. For isosceles, more specifically, they're congruent. And for any in general, not necessarily. So not necessarily trapezoids. And kites, it certainly also is not true, because you don't have parallel sides, so we're not going to do that. So the best we get are all types of parallelograms. Would be they're always supplementary. So if you could come up with a counterexample, so if like you're trying to list off, try to come up with a counterexample to like eliminate some. So like when we came with trapezoid, just quickly check. Just draw yourself like a general trapezoid and make sure that all those consecutive angles should add up to 180, supplementary in this case. And if you can find an example where they don't, then toss it out. All right, lastly, I'm not going to tell you what type of thing this is. You're going to classify this for me. Okay. What's the best possible name we could give each of these 4-sided figures, quadrilaterals? What's the best name I could come up with for this figure? Okay, so let's see. It's surely a parallelogram because it has 2 pairs of parallel sides. So this is at worst a parallelogram. Okay. All right. So then, if we want it to be more specific, what are some things we should start looking for? Let's look for characteristics of the more specific ones. So let's see. Could this be a rhombus? Okay. Does it have to be a rhombus? Okay, what should it do if it's going to be? What should things we look for if this is going to be forced to be a rhombus? Well, the parallel sides gives a parallelogram. We should look for perpendicular diagonals. Do we know those diagonals are perpendicular? Okay. What else should we look for if it's a rhombus? 4 congruent sides. Do we have 4 congruent sides? No. So it doesn't necessarily have to be it can't necessarily be a rhombus. If it's not a rhombus, what else can it not possibly be? Rectangles and rhombi are separate. A square is also a rhombus. So if it's not this, it can't be the square. It could be a rectangle. So now we got to check, is it possibly a rectangle? Well, think to yourself, folks, let's go back to your properties. What makes a rectangle a rectangle? What are some things you should look for to see if it's a rectangle? Tracy? Congruent diagonals. Does it have congruent diagonals? Yes. Therefore, we can write the rectangle. This is certainly a rectangle because the diagonals are congruent. All diagonals of a rectangle are congruent. It's a parallelogram with congruent diagonals. This is certainly a rectangle. Yes, Rachel. Well, see, they look 90, but like I could I mean, that's a parallelogram that doesn't have 90, so they don't tell me. It's the thing that really gives it away is the congruent diagram. Forces us to be a rectangle. How about this thing? What's the best name we could give this figure? Okay. So, what could I call this? Can you call this a rectangle? Okay, why not? Sides, we don't care. Rectangles, we don't care about the side lines. Those don't matter. I don't know that I have right angles over here. How do I know? Do I know these are parallel even? I don't even know these are parallel. So I don't even know this is a parallelogram, let alone a rectangle. I can't claim this must be a parallelogram. There's nothing that makes this segment parallel to this one. I just don't know. There's not enough information. I do know that I have at least one pair of parallel sides. So I can at least get a trapezoid. What would make that? What would make it an isosceles trapezoid? If the two legs are congruent. Do we know the two legs are congruent? No. I don't know that these are congruent. So the best name I can give this is a trapezoid.